This is an LED, or a light emitting diode. As you can see, it has two leads. The lead that is longer than the other gets connected to the positive terminal of a power supply, and the shorter lead gets connected to the negative terminal of a power supply. When we connect an LED to a breadboard, unless the LED is on your bad side, it's important to remember to connect a resistor in series with it. Without this resistor, the LED can burn out. In this, I'm using a 100 ohm resistor. Because LEDs can typically only handle 20 milliamps, 5 volts will ruin the component. To understand this, imagine the LED as a dam. In a dam, water can only flow one way. If the water becomes too high on one side of the dam, it will flow over the edge to the other side. Now imagine a tsunami going over this dam. There's nothing stopping this water from going over the dam and destroying everything on the other side. That's how an LED works when there's no resistor. Adding resistors is like adding walls that would slow down the tsunami to manageable levels. Putting this in context, when you connect an LED to a power source with no resistors, it can't limit current on its own. This leads to a large amount of current, similar to a short circuit with copper wire. Here's an example problem. If I have 5 volts and a resistance of 0.0001 ohms, I'll be trying to draw 50,000 amps. This is a ludicrous number, unless of course your power source is the sun. Using Joule's law, we can calculate the thermal energy this will make in 1 second. 50k amps squared times 0.0001 ohms times 1 second equals 250,000 joules of energy. That's enough to get copper wire red hot. In reality, what would actually happen is the LED would burn out instantly. The top number on the power supply is the voltage, and the bottom number is the current. I have this power supply running in fixed voltage mode, meaning that it always outputs 5 volts and will output however much current the circuit needs. It doesn't push current into the circuit. You may notice that something is off when looking at the current and voltage. The voltage reads 5 volts, and the current reads about 25 milliamps. And we know the circuit has a resistance of 100 ohms because the resistor we connected is 100 ohms. However, using Ohm's law, 5 volts divided by 0.025 amps is a resistance of 200 ohms. Don't worry, Ohm's law isn't failing and the world isn't ending. You have to apply it to the right part of the circuit. LEDs, because they give off light, will drop the voltage across them like a resistor does. To figure out this voltage drop, using Ohm's law of course, we get 0.025 amps times 100 ohms equals 2.5 volts. LEDs don't limit current, they drop voltage. Now, if we replace the 100 ohm resistor with something that has 10 times more resistance, we can expect a significant decrease in light given by the LED. When we turn on the power supply, we see a couple different things. The LED is dimmer and the power supply shows 0 current. This doesn't mean the current is actually 0. It's just so small that the power supply doesn't register. This little experiment demonstrates Ohm's law a bit clearer and you see the difference in action. What this experiment shows is that Ohm's law isn't just an equation, it's something you can see and measure. By adding resistance, we controlled the circuit, protected the LED, and changed its brightness. Through understanding this experiment, you're on the path to analyzing and making your own circuits.